Hello everyone, I am Dr. Fieser. I welcome you in my YouTube channel. Today in this video I am going to talk about Woodward Fieser rules. It is very important rule for UV visible spectroscopy. So Woodward Fieser rules are several sets of empirical derived rules which attempt to predict the wavelength of the absorption maxima in an UV visible spectrum of a given compound. Woodward-Fieser rule states that each type of diene or triene system is having a certain fixed value at which the absorption takes place, and this constitutes the base value or parent value. The contributions made by various alkyl substituents or ring residue, double bonds, extending conjugations, and polar groups such as chlorine, bromine are added to the basic value to obtain lambda max for a particular compound. Now, what is the history behind it? There is a Woodward and Fieser. In 1945, Robert Woodward gave certain rule for correlating lambda max with a molecular structure. In 1959, Fieser modified this rule with more experimental data, and the modified rule is known as Woodward-Fieser rule. Robert Woodward received Nobel Prize in 1965 for his extensive contributions in chemistry field. Now, Woodward and Fieser performed extensive studies on terpenes and steroidal alkenes and noted similar substituents and structural features would predictively lead to an empirical predictions of the wavelength for the lowest energy, that is pi star electronic transitions. Friend, this work was properly rearranged by Scott in 1964 into an extensive realistic on the Woodward-Fieser rule in combinations with comprehensive tables and examples. A more modern interpretation was compiled by in 1975. Now, conjugated organic compound containing two or more double bonds, each separated from other by single bond. Dienes, one of the class of organic compound containing two ethylenic linkages in the molecules. Endocyclic double bonds, in this case double bond lies within the ring. Exocyclic double bonds, in this case the double bond is attached extensively to the ring. Exocyclic double bond, and this is endocyclic double bond. Now, homoannular diene, cyclic diene having conjugated double bonds in the same ring. Heteroannular diene, cyclic dienes having conjugated double bonds in different rings. Now, base value. Acyclic conjugated diene, the rule begins with a base value for lambda max of the chromophore being observed. Acyclic butadiene 217. You see the butadiene. This is the base value. Now, the increment contribution of constituent is added to this base value for the group table. The standard conjugation plus 30, each exocyclic double bond plus 5, alkyl plus 5, OCOCH3 is 0, OR plus 6, SR plus 30, chlorine bromine plus 5, NR2 plus 60. Now, cyclic diene. There are two major types of cyclic dienes with two different base values, heteroannular and homoannular. Epsilon value 5000 to 15000 base lambda max, and epsilon 12,000 to 28,000 base value 253. The increment table is the same as for a cyclic butadiene with couple conditions. Additional homoannular plus 39. Where both types of diene are present, the one with the longer lambda becomes the base. Now, current value: acyclic 270 nanometer, hetero 240 nanometer, homo 250 nanometer. So, butadiene, annular diene, annular diene. Now, problems: alkyl substituents, ring residue, exocyclic double bonds, and extended additional conjugations. You can see the base value 270 nanometer, additional conjugation 0 nanometer, exocyclic double bond 0, ring residue 55515, substituents 0, expected 232, observed 234. In this molecule, base value 270 nanometer, additional conjugation 0, exocyclic double bond 0, ring residue 10 nanometer, substitutions 5 nanometer, expected 232 nanometer. Now this base value 270 nanometer, additional conjugations 0, exocyclic double bond 0, ring residue 20 nanometer, substituents 0, expected 237 nanometer. Now you can see base value 253 nanometer, additional conjugations 0 nanometer, exocyclic double bond 0 nanometer, ring residue 10 nanometer, and substitution 0, expected 263 nanometer. Now base value 270 nanometer, additional conjugation 0 nanometer, exocyclic double bonds 10 nanometer, ring residue 20 nanometer, substitutions 0, expected 247, observed 248. Now in this molecule, base value 270 nanometer, additional conjugation 0 nanometer, exocyclic double bond 0 nanometer, ring residue 20 nanometer, substitution 0, expected 237, and observed 237 nanometer. Now you can see here base value 270 nanometer, additional conjugation 0, exocyclic double bond 0, ring residue 50 nanometers, substituents 0, expected 232, observed 233. Base value 270 nanometer, additional conjugations 0, exocyclic double bond 5 nanometer, ring residue 10 nanometer, substitution 0, expected 232 nanometer. Base value 240 and additional conjugation 0, exocyclic double bond 5 nanometer, ring residue 15 nanometer, substitution 0, expected 234 nanometer, observed 235 nanometer. Base value 253 nanometer, additional conjugation 0, exocyclic double bond 5 nanometer, ring residue 15 nanometers, substitution 0, expected 273, and observed 275. Now you can see base value 253 nanometer, additional conjugation 30, exocyclic double bond 5, ring residue 15 nanometer, substitution 0, expected 303. In this case, base value 250 nanometer, additional conjugation 16 nanometer, exocyclic double bond 15 nanometer, ring residue 25 nanometer, substitution 0, expected 353 nanometer, observed 356 nanometer. In this case, you can see base value 270 nanometer, additional conjugation 0, exocyclic double bond 5 nanometer. Ring residue 10 nanometer. Substitution 0. Expected 232 nanometer. Observed 235 nanometer. Base value 270 nanometer. Additional conjugation 0. Exocyclic double bond 5 nanometer. Ring residue 10 nanometer. Substitution 0. Expected 232 nanometer. Observed 237 nanometer. So friends, you can see here base value 270 nanometer, additional conjugation 0, exocyclic double bond 0, ring residue 5 nanometer, substitution 0, expected 222 nanometer, observed 224 nanometer. In this case, base value 253 nanometer, additional conjugation 0 nanometer, exocyclic double bond 0 nanometer, ring residue 20 nanometer, substitution 0, expected 273, observed 265. In this case, base value 270 nanometer, additional conjugation 0, exocyclic double bonds 10 nanometer, ring residue 10 nanometer, substitution 0, expected 237 nanometer, observed 214 nanometer. Base value 240 nanometer, additional conjugation 30 nanometer, exocyclic double bond 10 nanometer, ring residue 25 nanometer, substitution 0, expected 279 nanometer, and observed 285 nanometer. So in this base value 270 nanometer, additional conjugation 30 into 3 90 nanometer, exocyclic double bond 0 nanometer, ring residue 506 5 into 6 30 nanometer, substitution 0, expected 337 nanometer. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.